number 34 says to find the line x equals c that divides the area under f of x on a closed interval from a to b to two equal areas. So that means that the integral from a to c of f of x dx equals the integral from c to b of f of x dx. In our example problem, we are looking for the area bound by y equals the square root of x and y equals 0, and we want to find the line x equals c on the closed interval from 0 to 4. For this part of the problem, we have the integral of the square root of x dx from 0 to c, and you set it equal to the integral of the square root of x dx from c to 4, and then when you take the antiderivative, and then from there, you plug in the top number minus plugging in the bottom number on both sides. So c is equal to 4 to the 2/3.
For problem number 35, we're trying to find the derivative of the integral from a to x of f of t dt when a is a constant. For our example problem, we're trying to find the derivative of the integral from 4 to x of 3t squared minus 1 dt. Since it is the derivative of an integral from a given number to a variable, you can just substitute in x for t, so we find that the answer is 3x squared minus 1 because the derivative and the integral cancel out. Problem number 36, we're trying to find the derivative of an integral from a to u of f of t dt when a is a constant and u is a function. For our example problem, we're trying to find the derivative of an integral from 4 to 3x of 3t squared minus 1 dt. Since it is 3x and rather than just x, you have to use the chain rule. After all of the arithmetic, you just sub in 3x for t, and after the arithmetic, you find that the answer is 81x squared minus 3.
For number 37, they're asking you to find the rate of change of population, and really to do that, you're just mostly looking for the first derivative, because the original function is usually p of t, which is just the population, and the second derivative is usually the increase or decrease of the actual rate of change. So what you're trying to find is the rate, which is usually the first derivative in these cases. For the example that I found, I had an original function p of t equals 3e to the t over 1 plus e to the t, and it told you that p was measured in thousands of people, and that t was the number of years, and since it's the number of years, t is going to be greater than or equal to 0, and they want you to find the rate of change at t equals 2. And in this case, because of the givens, the rate would be in thousands of people per year. So all you have to do is find the first derivative of the original p function. So you just do low d high minus high d low over low squared, which I have right here. And then once you have that, all you have to do is plug in the 2, because that's what they told you your t value was. And since this was a free response question, you can just leave it like this. You don't have to simplify. And your units are thousands of people per year. And I also did one at the bottom that's in case they give you the second derivative, which sometimes they'll do. It's really just the same thing. You just do it backwards because you do an integral. So instead of finding the first derivative by taking the derivative, you're going to find the first derivative by taking the integral. But it's still the same process. Number 38 on the final review sheet, they're asking you to find the line y equals mx plus b that is tangent to f of x at a comma b. Now when you're thinking about a line of tangency, you want to find the derivative of the function. So in this case, you're wanting to find f prime of a, because they tell you that it's tangent at a comma b. Now they give you the equation f of x equals 3x squared minus 6, and they tell you that they want you to find the tangent line at x equal 1. Okay, so to find the original point at x equal 1, you just plug in 1 to the original equation, and you get 3 times 1 squared, which is 1, times the 3 is 3, minus 6 is negative 3. So your original a comma b point is 1 comma negative 3. Then you have to find the derivative of the equation, and you do that by multiplying the coefficient by the exponent and bringing it down a power. So then you have the 6x minus the derivative of a constant, which we know is 0. So your derivative equation is 6x. Then to find f prime of a, which in this case is 1, you'll find f prime of 1 by multiplying the 6 times 1, which is 6. So now you have your slope and your original point to write your tangent equation in point-slope form. So you have the y minus the y value in your a comma b point, which is -3, so it's y minus -3, which is the same as y plus 3, which equals the slope, which is 6, times x minus the x value in your a comma b point, which is 1. Then by multiplying it out and combining like terms, you get y equals 6x minus 6 minus 3, which is the same as your final tangent line, which is y equals 6x minus 9.